So for today, we're going to be looking at more factoring. We're going to do two more types. So we're still taking a break from Chapter 6. We're on day 4, and we're going to do two different types. The first one we're going to do is how you're going to factor by something called grouping. And then the second one will be a difference of two squares. So I'll spend the first half talking about grouping, and then we'll go to difference of two squares. So far we did two things. We've done GCF and we've done the shortcut method. So GCF can be applied to any number of terms, but the shortcut method was only for trinomials. Now we're going to look specifically at doing GCF. We're going to focus on doing that. And if you're good at doing that, you should be fine with this grouping. So far we factored out GCF. And we did the shortcut method with trinomials. So now we're going to be looking specifically by grouping, which will contain usually 4 terms. So we need 4 terms to do grouping. And you'll see why whenever we actually start to do it. So I'm going to go through the directions on how to do it, and I'm going to apply it to the problems that are down here. Now, if you look down here, we have x cubed plus 6x squared plus 8x plus 48. If you notice, there are 4 terms here. 1, 2, 3, 4. So we need to have that to do grouping. And you can look at the other one as well. There's also 4 terms here. And if you look at this one, let's look at this one over here. This would be one of the cases where if you were to look at it right now, you wouldn't know what to do with it because you could try GCF, but the problem is if you look at the numbers, 2, 5, 6, 15, nothing goes into all 4 of those numbers. Then you could try a variable. Does anything go into all these variables? Well, no, there's not a variable in the end one here. So you couldn't even factor out a variable. So what do? We're going to try something called grouping. So I'm going to try it with this first problem as we read through the directions on how to do it. So directions for factoring by grouping. First, you're going to put sets of parentheses around the first 2 terms and the last 2 terms. So let's go ahead and do that. So in this problem down here, I'm going to put a parentheses set around the first 2. 1 parentheses set. And then we're going to put the parentheses around the second set. This is where they get the term grouping. Okay, so that takes care of that. Then we're going to factor a GCF from both sets that we just made. So both sets of parentheses. So let's go back and look over here. And let's see. What GCF do we have now if we just look at the first 2 terms and the last 2 terms? Well, the first 2 terms we can look at, there is x squared would be the lowest power between those 2 that you could factor out. So I'm going to write x squared. And then we write what's left. So if you remember, it's like we're subtracting it out from each one. So 3 minus 2, so there's 1 left. And then we have plus, take 2 out of that one, there's just 6. All right, let's go to the next one. We have 8x and 48. What goes in both of those numbers? That GCF would be, I believe, 8. So I'm going to put a plus 8 because it's a positive 8 we're pulling out. And then the rest of the parentheses, divide everything by 8 in here. We get x to the first plus, divide that by 8, we get 6. Okay, then we're almost actually done. We did 2 GCFs. We split the problem in half, basically. So let's go ahead and cover the rest of this. And then we're going to pull out the GCF that is in common between both terms. So this one's a little weird at the end. But I think after you do a little bit of it and you practice it, it actually ends up being really simple. So let's go ahead and highlight this. So this here is a term now. You have 2 things being multiplied together right here in the middle. And then you have this big plus sign here. And this whole part here is also a term. So we're going to pretend that these are 2 terms, right? Because they actually are. We have 1 term here, 1 term here. And we're going to ask ourselves, well, what's in common between these 2? And I hope it's very obvious that you can see the entire parenthesis set of x plus 8 is in both, x plus 6 is in both of the terms. So we're going to say, okay, well, that's what's in common. So let's factor that out as a quantity. So it's going to come out in the front. So I'll write it as a set. x plus 6. And then when you do that, remember, we're taking this out of both these two terms. So it comes out of that one, and it comes out of that one. And then we write what's left in parentheses. So it's kind of like we're taking out the x plus 6 from both of them. What do we have left? All we have left is x squared, because that's crossed out, plus 8. And so whatever we have left, we put in another set of parentheses, x squared plus 8. And that's actually it. Now I'm going to do this real quick, but you could actually multiply this back out, and you would get these 4 terms. So I wouldn't write this part, but we could try it, right? You could do x and x squared. That gives you a total of x cubed. There's your first term, right? X and 8, that's 8x. Oh, that's that term right there. 6 times x squared, that's going to be 6x squared. And then the last one would be 6 times 8, which is 48. So it might be in a slightly different order here, but we got all 4 terms, and nothing is a like term, so they can't be combined. So again, you don't have to write all that out. I was just showing you that it actually does work. Okay, let's try part B. So I'm going to go through the directions again. Put sets of parentheses around the first 2 terms and the last 2 terms. Let's do GCF. What comes out of the first set? No number, but a variable. Again, x squared. What comes out of the second set? Oh wait, I should finish this up. If we take out x squared, we have 2x. Still in here, plus, take out x squared here, 5. Go to the second set here, we have 6x plus 15. What goes into both of those? That would be 3. I'm going to take out a plus 3. And then divide them both by 3. We get 2x plus 5. So I don't know if you noticed, but we get the same thing again, right? These two things are the same. So that would be your new GCF between the 2 terms. And again, once you do this a couple times, it's really not that bad. I'm going to take out a 2x plus 5. I should probably go back to my pen. 2x plus 5, because that's what's in common between both of these. So it's like I'm crossing them out. And then what do we have left? X squared plus 3. Right next to each other in another set of parentheses. There it is. And that is your final answer. Not too terrible, hopefully. I'm going to try 2 more, and then we'll go to our fourth type of factoring. Example 2, factor the polynomials below by grouping. All right, so let's do that. Put our 2 sets of parentheses on both of these here. Take out what's in common in the first one. Nothing goes into 3 and 4. However, we can take out an n squared. And we'd be left with 3n minus 4. I don't know if you noticed this, but this 3n minus 4 already matches what we have up top here. Another 3n minus 4. So what do we do here? Well, for one, there is no GCF in here as well, right? Like 3n and minus 4, there's no GCF here. So whenever that happens, usually we would say it's like not factorable, but we have to have something here. And so what we're going to do here is we say, what's the GCF? Nothing but, if you remember, we could say it's 1. So I'm going to put a plus 1 here. And then what is that going to change in here? Literally nothing. We're going to write it again. 3n minus 4. Taking out a 1 doesn't change what's in the parentheses. So what's our final answer? We're going to take out a 3n minus 4. And then we have left n squared plus 1. Got to have that plus 1. Notice if you did not have the plus 1, right, if I crossed it out, and you distributed the n squared, you would only get 2 terms. You wouldn't get all 4 of these terms. So it's pretty important that you have that plus 1. That's what gives you 4 terms whenever you do the arches and distribute. Okay, last one. This one looks a little different. I don't know if you noticed here, but we have, a y in the middle here. We have x squared. We have a y over here. Also, after I put my parentheses on the first set, we have 2 negatives over here. So whenever I do it with a negative, I'm going to go ahead and include the negative in my parentheses set when I'm grouping them, and you'll see why in a second. When we do the GCF here in the first set, we're going to have 2 positive numbers inside the parentheses. We want to have the same thing going on over here, but right now they're both negative. So we'll see how we deal with that after we take out the GCF here. So what comes out of this one? We We can take out a 5 from 5 and 20. We can also take out an x squared. All right, so what happens if we take those out? We get a y plus, divide that by 5, you get 4. Take out the x squared, nothing. So we want this to be a y plus 4. Otherwise, we would not be able to finish the problem. We need them to match up every single time. So let's go ahead and pull out. What do you think you should pull out here? Probably not just 2, but a negative 2. So you represent that as a minus 2. So how will that fix things? If you divide these by a negative 2, it becomes a positive y. Negative 8 divided by a negative 2 plus 4. There we go. We have them matching. Let's go ahead and write it in. Y plus 4, and whatever's left, 5x squared minus 2. That's all for grouping, and you should try them on your own. There's a team huddle. There's 4 problems. You should finish those yourself. And then we'll move on to the special case factoring, which is the difference of 2 squares. So I would take a moment and try the huddle problems first, and then move on to this. We'll wrap it up. Okay, so let's go ahead and move on. Sometimes binomials can be factored. I don't know if you remember what a binomial is, but the prefix bi would mean 2. So we're talking about 2 terms. And that will come up in a little bit. So besides doing GCF with binomials, there's something else we can do. But it's only possible if you have a difference of squares. So let's talk about what these words mean. When I'm talking about when I talk about a squared number, whenever I say like, what's a perfect square? Can you think of what I mean when I say perfect square? I'll give you an example. 9 is a perfect square. Why is it a perfect square? Because it equals 3 squared. Or 3 times 3, right? What's another one? Let's try 49. That's a perfect square. Why? It's 7 squared. So if you know your perfect squares, it applies to these problems, and it'll be pretty easy to do. What's another one? Let's do, what about 25, right? That's 5 squared. What about 144? That one is 12 squared. So what we're looking for are these perfect squares, like 9, 49, 25, 144. And most likely you'll see numbers anywhere from 1 to 12 or so being perfect squares. So we're looking for that. If we're looking at a variable, what we're looking for is either x squared, or it could be x to the 4th, something where you can split it up into 2 and 2, right? You could have x to the 6th, because that would be 3 and 3, right? It's a little different when you have powers. So we're looking for that when we talk about difference of squares. The word difference simply just means subtraction. So we need subtraction between them. Let's go ahead and fill in what a difference of squares is. So it is a binomial where we have 2 terms. There's only going to be 2 terms, but we have to see if they're perfect squares, like the numbers up above, or the variables here. And we have to make sure that there is subtraction between those 2 terms. So let's try a forward example of something we already know how to do. So this is what we'll eventually be factoring, but let's go forward with it. So we're going to multiply these 2 together. So let's see what happens. If we do x times x, right, we're going to do our arches. That's x squared. Then you do x times positive 3, 3x. Then we do negative 3 times x. Don't forget there's a negative sign here. Minus 3x. And then negative 3 times positive 3. Minus 9. So notice what happens here. We got 4 terms. However, at the end, we're not going to have 4 terms. 3x minus 3x, that goes away. They cross each other out. So what do we have left? X squared minus 9. Now, do we notice here we have subtraction between 2 terms? It's a binomial, right? And both terms are perfect squares, right? X squared is x times x, and 9 is 3 times 3. The question is, how do we start with a problem like this and go backwards to this? That's what we're going to do, which is called the factoring portion, is going backwards. And I hope it's kind of obvious to see. You have x times x, so that's what we put here. I should highlight it probably. We have x here and x here. That's how you get your x squared, right? So where does the negative 9 come from? That's just the other two positions. Negative 3 times positive 3, negative 9. But they have to be perfect squares because we put the same number in there. One positive, one negative. Why does it have to be a positive and negative? That's where this occurs. One positive, one negative. That's why they cancel out every time. As long as they are opposite signs, you can do that. So looking at this example of going backwards, right, x squared minus 9 to the original, how can we do this just by looking at it? Now using what you know in part A, which is up here, factor the following. What would x squared minus 4 look like? Well, let's just kind of follow the generic kind of method up here, what it looks like. We know we're going to have two sets of parentheses. We just have to figure out what goes in there. The x squared part comes from having x and x, so we're going to copy that the same way. And here we have 9, but where did that come from? The fact that it was a perfect square, 3 and 3. Negative 3 plus positive 3. Here we have a perfect square. What is 4? That's 2 and 2. So we're going to have a positive 2 and a negative 2. And that's it. That's considered factored. If you were to multiply these back together, you would end up canceling out a positive 2x and a negative 2x, and you would get x squared minus 4. Because remember, x squared is also x times x, so you can also put that in here. So we're going to be practicing this, but you have to recognize what is a perfect square. So here's the formula, and if it's confusing, that's okay. I'd rather you just kind of figure out how to fill in the blanks with the parentheses anyway. But here's what it says, the formula. If you have a number squared, or variable, whatever, with a subtraction sign, and another number squared, then the formula says it's going to be equal to a plus b, right? Not the squared version, but just a plus b, times the other set, which is a minus b. So we're going to try 2, and then the rest will be for you to do. So factor the following. We have 4x squared and minus 25. Now remember, it has to have a minus sign. So we're going to be good with these two problems here. The minus sign is right there. So the way I approach this is we already know we're going to have two sets of parentheses. But the question is, are they both perfect squares? So what is 25? That's 5 times 5. All right, so that actually fills in our outside spots here. So we have 5 and 5. We know we have to get a negative 25, so we know we have to have a plus minus. That's going to happen every time with difference of squares. And then how do you get 4x squared? So not only do we have a number, we have a variable together. Well, how do you get 4? That's 2 and 2. And then how do you get x squared? You have to split that up and say x and x. So this would be 2x plus 5, 2x minus 5. As long as you know your perfect squares, it should be fine. All right, last one so we can wrap this up. So we look here, we have some x squared and a y squared, so they're good squares. That's good. They're perfect squares. The problem is we have 18 and 32. They are not perfect squares. 18 is like, 9 times 2, 3 times 6, 18 and 1. It's not going to work. You've got to have the same number. 32 also gives us an issue. So what do we do in this case? We're going to go back to the very first thing we learned, which is GCF. See if there's a GCF first, and then we'll see what we have left. So we're going to do GCF. So do we have one? Not with the variables, but with the numbers. What goes into 1832? I think it's only 2. So I'm going to factor out a 2 from both of these. Right? So that means we're going to divide both of these by 2. So we get 9x squared minus, divide that by 2, 16y squared. So that might be the only thing you can do in some problems, and we would circle it and be done. However, you should always now check to see if we have difference of squares. We have our subtraction sign. Are both of these perfect squares? 16 is 4 and 4. We'll also split up the y's. And then 9x squared is 3 and 3, x and x, right? So here's going to be our answer. Now we can change this from one set of parentheses to two. We're going to bring the 2 down, make 2 sets of parentheses, and just fill in our blanks. We have 3x, 3x, 4y, 4y. Got to have opposite signs, plus minus. And that's it. Final answer here. Final answer here. So now you should be able to finish the huddle, which is all practicing difference of 2 squares. I don't know if you noticed, but like if you look at part B here, these are both perfect squares, right? 36 and 9, because 36 is 6 times 6. And then we have 3 times 3. However, there's a GCF you can take out first. 9 actually goes into 36, so you can do this by dividing by 9 and get 4x squared minus 1. And that's actually the preferred way to do it. Do GCF first, which is what we did. We did GCF. And if you look at what's left, we actually still have difference of squares. How do you get 4? 2 and 2. How do you get 1? 1 times 1. So we'd have the 9 on the outside, and we would split this up and say, okay, well, we have 2 with x's getting split. So 2x, 2x. 1 gets split by a 1, 1, positive, negative. So I did one for you. You should always look for that first. There's not many of them that have a GCF first, but you should always look for it. And to finish off that section. And then Team Mastery, same thing. It's going to be a mix of all of them together, and you can finish that as well. All right, that is it for day 4 of doing grouping and difference of squares. So now we have 4 different types of factoring done for, and so we can move on and do one more type, I believe, and that will finish up this mid-chapter 6.